We're now on to rule 5 of indices. We're almost there, guys. Okay, we've got 8 to the power of negative n, and we've got to work out a general solution for this one. So to do this, I'm going to look back at our previous example where we had 8 to the power of 0 equals 1. So we went and used the base 3 system and the base 2 system, and that proved y to the power of 0, we got 1. But looking at the pattern here, we're at 3, 2, 1, 0. The next logical number in that pattern is negative 1. So 3 to the power of negative 1. In each of these iterations, we have to divide by 3. Well, the problem is 1 doesn't divide by 3 and give us an exact number. However, we can go and express this as a fraction. 1 upon 3. Now, if we do that again, let's divide that by 3 again. We've now got 3 to the power of minus 2. A third of a third is 1/9. Because 1 over 3 times 1 over 3. Top times top is 1. Bottom times bottom is 9. We're learning more about fractions in a different video. So what we can say then, because we know that 3 squared is 9, I could rewrite this as being 1 over 3 squared. So what's just happened here? I could say that's 1 over 3 to the power of 1 as well then. If I've got a negative power, my base goes to the bottom of a fraction and the power becomes positive. Same here. I've got a negative power, the base goes to the bottom of the fraction and my power becomes positive. Let's show that works with the 2's as well. Half of 1 is 1/2, which we know is 1 over 2 to the power of 1. We also know that 2 to the power of negative 2 is 1 over 4. Half of a half is a quarter. We know that 4 is 2 squared. So this is 1 upon 2 squared. So the same rule applies no matter what we're looking at here. So our general rule of thumb is, if I've got 8 to the power of minus n, that's simply 1 over 8 to the power of positive n. Now that might look confusing to begin with, so let's do some examples just to make sure we know what we're doing with this. So first of all, we've got 5 to the power of negative 1. Well, we know that the 5 goes to the bottom of a fraction, so it's 1 over 5 to the power of 1, which we know is just 1 over 5. 7 to the power of negative 2, 1 over 7 squared, or if you want, 1 over 49. And then we've got 1 over 8 cubed, which is 1 over, let me get this right, 8 times 8 we know is 64, so 64 times 8, because not all of us know our cube numbers off the top of our head straight away. 8 4's 32, 8 times 6 is 48, plus the 3 is 51, so 512. But you can still see minus 3, positive 3 here. Simpler examples is when we always include the algebra. So h to the power of negative 11, 1 over h to the positive 11, r to the negative 5, 1 over r to the power of positive 5. And then we can move on to the numbers then. Ones we've got coefficients as well. These are always the ones that try and trick people, and they trip people up on a regular basis. So in this one here, we have to think to ourselves, well, where's this 1 come from? I could say this is 1h to the negative 11, or 1r to the negative 5. So the 1 goes to the top, and the h to the negative 11 goes to the bottom. So hang on, that means that on the top this time, I've not got 1, I have in fact got 3. On the bottom, q to the power of 4. Now that's different from this example. And again, looking back at rule 3 of indices, we know that if we've got everything in the pair of brackets and the power on the outside, everything must be raised to that power. So this is one lot of that. So we've got 1 over 3q all to the power of 4. Or if you want, 3 to the power of 4, well, 3 times 3 is 9, times 3 is 27, and times 3 a fourth time gives us 81, q to the power of 4. There you have it. So that's 5 rules down. We have 2 more to go. Next one we're looking at fractional indices.